This is the plan and this is the front elevation of a solid object. Can you imagine the shape of the object from its two projections shown here? How many objects do you think have the same plan and front elevation? Let's see. The object can look like this, or this, or this. All of these objects have the same front elevation and the same plan. How do we determine which object is being referred to by the given plan and front elevation? We already know what the object looks like from the top view and the front view. So, to help us determine the actual shape of the object, we need to know what the object looks like from another angle, which is from the side view. Based on these three projections, we can now determine the shape of the object. It is the second object. When an architect designs a building, or when an engineer designs a machine on paper, at least three types of drawings are shown to help other people visualize the shape of these objects. They are the plan, the front elevation, and the side elevation of the objects. These are examples of the side elevation of several objects. Previously, we have learned how to draw the plan and the front elevation. Today, we are going to learn how to draw the side elevation of an object. Example 1. Draw to full scale the side elevation of this object as viewed from X. The side elevation of an object is actually its orthogonal projection on the vertical plane. If it is viewed from X, then the vertical plane is perpendicular to the direction of X. So, what does the orthogonal projection look like? It is a square with a horizontal line bisecting it. To help us draw plan and elevation accurately, especially if it involves measurement and right angles, we can use a graph paper as a guide. It can be a 1 mm or 2 mm graph paper with 1 cm major grids. Place a blank piece of paper over the graph paper and proceed to draw the side elevation of the object. Remember to include the labels and the measurements. Example 2. Based on the information given, draw to full scale the side elevation of this object as viewed from X. So, what does the orthogonal projection look like? It is a circle with an equilateral triangle in it. Now, place a blank piece of paper over graph paper as before. We will draw the triangle first. The sides of the triangle are 3 centimeters. So, draw a horizontal line of length 3 centimeters. Then, draw lightly a vertical line bisecting the first line. Use a ruler to measure and draw the other 2 sides of the triangle, each of length 3 centimeters also. Next, we need to find the center of the triangle, which will be the center of the circle. Find the midpoint of this line, and then draw lightly a line from the opposite vertex to the midpoint. So, this is the center of the triangle and the circle. Thus, we can use a pair of compasses to draw a circle of radius 2.5 centimeters. Finally, rub off any unwanted lines and include the labels and the measurements of the side elevation. For our next example, we are asked to draw to full scale the plan, the front elevation as viewed from X, and the side elevation as viewed from Y of the given object. Note the extra information given in the question which is not in the diagram. To draw these plan and elevations, we can choose either to draw them anywhere on a blank piece of paper, or we can position them systematically. For this question, we are going to choose the latter one. The way we are going to do this is by dividing a blank piece of paper into 4 quadrants. As usual, we will use a graph paper below it as a guide for measurements. So, where do we draw our plan and elevations? It is always a good idea to draw the plan and the front elevation in the same column and the front and side elevations in the same row. As the view from X is the front view of the object, then the view from Y is the view from its left. So, we will place our side elevation in the left column. Hence, the plan and the front elevation will be in the right column. We will draw the plan first. We start with the 8 cm by 9 cm rectangle. As BC will be the base for the front elevation, BC will also be the base for the plan. Complete the plan with the given labels and measurements. Next, we draw the front elevation. To do this, we draw lightly projection lines from each corner of the plan to the front elevation part of our paper. Use these projection lines as guides to draw the front elevation. Complete it by including the labels and the measurements. Finally, we will use the plan and the front elevation to help us draw the side elevation. Once again, we draw projection lines from the plan and the front elevation to the side elevation part, which should be in the same row as the front elevation. The angle here must be 45 degrees. The last step now is to complete the drawing. Example 4. Once again, we are asked to draw the plan, the front elevation, and the side elevation of the given object. In this question, as the view from X is the front view of the object, then the view from Y is the view from its right. So this time, we will place our side elevation in the right column. Hence, the plan and front elevation will be in the left column. We will draw the plan first. We start with a 6 cm by 5 cm rectangle. As KL will be the base for the front elevation, KL will also be the base for the plan. Complete the plan with the given labels and measurements. Next, we draw lightly projection lines from each corner of the plan to the front elevation part of our paper. Use these projection lines as guides to draw the front elevation. Complete it by including the labels and the measurements. Next, we draw projection lines from the plan and the front elevation to the side elevation part, which should be in the same row as the front elevation. Remember that the angle here must be 45 degrees. Finally, we draw the side elevation of the object, complete with labels and measurements. Example 5. The difference in this question compared to the previous ones is that the side elevation is now on a vertical plane, which is parallel to the diagonal AC as viewed from Y. Hence, we will need to place the plan and elevations differently this time. Let's draw the plan first. We start with a 7 cm by 6 cm rectangle. Complete the plan with the given labels and measurements as usual. For the side elevation, the base is AC. So, first we need to draw projection lines from the plan perpendicular to AC. You can use your protractor or set square and a ruler to make sure that the lines are perpendicular to AC. For example, this is how we can draw a line perpendicular to AC from point B. Then, draw line AC for the side elevation and make sure that the line is also perpendicular to the projection lines. The frustum's height is 5 centimeters. So, measure 5 centimeters from the base to locate points E and I. Complete the drawing and include the labels and measurements. In today's lesson, we learned about how to draw the side elevation of a solid object. The side elevation of an object is its orthogonal projection on a vertical plane. We also learned how to draw and arrange the plan, the front elevation and side elevation of a solid object systematically on a single piece of paper. The side elevation is not necessarily parallel to the edge of an object. It can also be parallel to the diagonal of the base of an object.